Okay guys, so we're gonna start on PowerPoint for Vectors Day 3. So I skipped over the first slide that just says Vectors Day 3, and we're gonna start on the second slide that starts with dot product. So there are two types of vector multiplication, the inner product and the outer product. The first that we will examine and use is the inner product, which is commonly called the dot product. So if you see like right here where it says V dot in the middle, like the multiplication symbol, and then W, we call that V dot W, or the dot product between V and W. So that's what we're going to be doing. Here's the definition. If V is this A1, B1 and W is A2, B2, then the dot product is defined as V dot W is A1 times A2 plus B1 times B2. So let's look at example 1. V dot W. Okay? So V is 3, 5. And W is negative 2, 2. So V dot W, well, remember, it's A1, A2 plus B1, B2. Right here. So A1 would be 3. A2 would be negative 2. Okay? And then plus B1, which is 5, and B2, which is 2. So 3 times negative 2 is negative 6. 5 times 2 is 10. Negative 6 and 10 is 4. So the dot product is 4. Okay? Let's look at number 2. It says W dot V. Well, W dot V would start with W first. So negative 2 times 3 plus 2 times 5. But you still get negative 6 plus 10, which also is 4. Okay? Alright, so let's look at number 3. It says V dot V. So V is 3, so now it's 3 times 3, because A1 and A2 are the same number, plus 5 times 5. So then you get 9 plus 25, which is 39. It's really simple to do. You just have to know what a dot product is. It's actually not too difficult to find. Okay. So this is just saying that given this vector v equals x, y, then the magnitude v squared is equal to the square root of x squared plus y squared, which is just x squared plus y squared. Okay? So it's just saying that if you have a vector dot itself, then it's just, you know, it's pretty self-explanatory. It's giving you a really in-depth definition of what's going on when you take a vector and you dot it to itself. Okay? You don't need to memorize this or anything. It's just a little conceptual stuff so that you realize that V dot V is the magnitude V squared. Okay. All right. So So, find the magnitude of vector v using the dot product. Well, if we think about that the previous problem, or the previous thing, it said that the magnitude of v squared was x squared plus y squared, which was v dot v. So then v dot v is the magnitude squared. So if we do the dot product, so v is negative 2, 6. Okay, so if we do the dot product, we have negative 2 times negative 2. Let me write that bigger so y'all can see it. Negative 2 times negative 2 plus 6 times 6. Negative 2 times negative 2 is 4. 6 times 6 is 36. And 4 plus 36 is 40. So then 40, which is v dot v, must equal the magnitude of v squared. So then if the magnitude of v squared is 40, then the square root of 40 is the magnitude of v. Okay? So let's do the magnitude the way we did it before. Okay? So if we have a vector, negative 2, 6, got this vector right here. You get this right triangle. This is 2, 6. So if we go, okay, well then the hypotenuse, 2 squared plus 6 squared, and the square root of that equals c, the hypotenuse. The square root of 4 plus 36 is the square root of 40. Hey, look, works out. Okay? So it's just another way of finding magnitude using the dot product rather than Pythagoras. Okay? Okay, so this is just a real quick to show you what's going on. If we have these 3 vectors, or really just need 2, but we have vectors going on. We can find the angles between 2 vectors. Okay, so that's what this is talking about. So we're going to be able to find the angles between these vectors. That's just a way to show you what it looks like with a picture. So here's the actual formulas. So this is why we have this other formula, and it's because we use this to find the angle between the vectors. Okay? So here's the basic. These are both the same formula, just rewritten different ways. So here is the formula the way that you would see it in a book. Okay? And if you do some algebra, if you divide by magnitude u times magnitude v, then you get u dot v over magnitude u magnitude v equals cosine theta. And then to get theta, you just take the inverse. But I went ahead and gave you this formula so that if you need theta, you can just plug in what you know and get the answer. So it's a little easier for you to solve out once you have that other formula. Okay, so let's look at an example. So it says, find the angle between the vectors. V equals 3, 8. And W is, what was that, 1, 7? Yeah. 1, 7. Okay, so our formula for angle, remember from the previous slide, was theta is the cosine inverse of U dot V over magnitude U magnitude V. Okay? So we need to do U dot V. So first let's do that. So 1 times 3, or this one times this one, or this one doesn't really matter. V times W, 3, 1, and plus 8 times 7. That's U dot V. Okay? Now we need the magnitude of V and the magnitude of W. Well, if you remember, there's 2 ways to do it. I like to just do the square root of the first one squared plus the second one squared. That's W. That's magnitude W. Okay, so let's do that real quick. Magnitude of W is the square root of 1 squared plus 7 squared, which is the square root of 50. Okay, and then the magnitude of V is the square root of 3 squared plus 8 squared, which is the square root of 9 plus 64, which is the square root of 73. So then this is square root of 50 times square root of 73. And we just take the cosine inverse of all this, and it'll give you the solution. So let's see, cosine inverse. This is 3 times plus 56. Right? Yeah, 56. So 59 over root 65. Just put it in a calculator. I don't feel like doing it in my head. Okay, so 50 times 73. 365. Okay, so I'm gonna put the calculator over here so they can see what I'm doing on the. Alright, so once you get there, you can just put this in the calculator. Cosine inverse of 59 divided by the square root of 3650, and you get 12.42. Make sure you're in degrees, and that's your answer. So the angle theta is 12.43 degrees. All right, so let's look and see if this makes sense. Because remember I say this, make sure your answer makes sense. So let's look at the graph and see these two vectors. Vector V is at 3, 8. So it's up here. So it looks like this. Vector W is at 1, 7. 1, 2, 3, 4, 5, 6, 7. So it's right here. So, now ask yourself, does this angle look like about 12 degrees? To me, yeah, it looks like it's about 12 degrees. That makes complete sense. So the last thing you should always do is make sure that your answer makes sense. Okay. So now two vectors are parallel if they have the same or opposite direction. So all that's saying, guys, is that you have the same vector and it's going in the same direction. So let me use my little graph over here. If we have this vector right here, and we have this vector right here, they're parallel because they're both going in the same, it's the same vector, just going in different places on the graph. Okay? If two vectors travel in the same direction, then the angle is 0. Well, that makes complete sense. If this vector and this vector are both going together, one on top of the other, then there is no angle between them. Okay? If two vectors are traveling in the opposite direction, so I have this same vector v, but now I'm going this way, negative v, then the angle here is 180 degrees. That makes complete sense, right? So this is just some more kind of conceptual stuff, just to get you thinking about it. Okay. So now we're going to do what's called orthogonal vectors. So two vectors are perpendicular in 2D are called orthogonal. The angle between orthogonal vectors is 90 degrees. So that's these right here. So if you have this vector and you have this vector, and this angle here is 90 degrees, then they are orthogonal. Okay? And then this is just some more conceptual stuff, but it says the dot product for orthogonal vectors is given this, and the cosine of 90 is 0. So then the dot product between orthogonal vectors is always 0. Okay? Now, zero vector. Zero vector is not, this is not a scalar number, okay? Okay, it means that the vector is 0. Okay, basically, it's this dot right here. That's a 0 vector. That's a 0 vector. Okay? Does that make sense? It isn't 0. It's a 0 vector. Okay? And so the 0 vector in component form is 0, 0. The dot product from the 0 vector to and any general vector is also 0. And the 0 vector is orthogonal to all other vectors. Okay? It's just some, you don't need to memorize this or anything, but it's just some stuff you should understand, that 0 is a vector. Okay? Alright, so now let's work this last example. Find the value of k so that the vectors v and w are orthogonal. Well, we just said on the previous slide that the dot product of orthogonal vectors is 0. We just said that. That was on the previous slide. So if the dot product between them is 0, and V is negative 3i plus kj, where k is something we want to find, and W is 2i minus 5j, then we can do the dot product. The dot product will be A times A, so A1 and A2, plus B1 and B2. So then negative 3 times 2 plus K times negative 5 equals 0. All right, so negative 3 times 2 is negative 6 plus K. Here, I'm going to rewrite this as negative 5K. Move the 6 over, and you get negative 5K equals 6. And now just divide by negative 5. So then K is 6 over negative 5, or K is negative 6 fifths. Not too hard. All right? So, you should be able to do the assignment that I've given that goes with this vector notes. If you have any questions, email me, or you're welcome to show up for the tutorial sessions I have posted on Google Classroom. Other than that, I'll see y'all in the next video.